Yeah.
So, firstly, I'm feeling horrible, so I may not stay for this entire session.
Okay, that's fine as long as you don't feel terrible for us. When you say terrible, I was sort of, oh, what I did.
He feels terrible for us that he comes here.
Yeah, okay.
Deal. So, horrible.
Take care.
Yeah. Are you going to talk to the working group about that court request?
Do you want us to go to it?
Because there's a process that has to be followed in a group consensus, and you have to be very clear and specific about what you're asking for. So that's the court request. The other thing about the multicast, the address/group, that I skimmed through that discussion that happened. That was so unclear that it seemed like there was no strong consensus there that the address was before. I'm just kind of trying to understand precisely what you want.
Yeah, we'll fix that. I mean, thanks for sending the list, the actual procedure, because I knew there was one, but I didn't know what it was. So what I'm going to do, next revision of the draft, we'll try and get the IANA consideration section in a status such that generating that request is trivial.
Okay, so if we're going to do that, we're probably then not going to try and do consensus call for it right here. Because if you wait, I mean, you can egg problem.
Yeah, but I'd rather the draft be stating the requirement of the request to IANA exactly right, and have a consensus call on that rather than.
Right. That's
personally,
much better.
But I'm not working group chair, so I don't get to decide.
You could do so.
I think that's
a good way.
Following the process details. The only gotcha that I can imagine is that about 2 years ago, I did exactly the same request for proprietary implementation.
Yeah.
Hopefully nobody remembers. We already requested an autonomic TCP/IP and multiple.
But did you get one?
Yeah, I did get that.
Oh, well, I can steal that. I put that in my implementation immediately.
Okay, so
Cool.
Yeah.
And a consideration section is just TBD,
Yeah.
something where it's appropriate.
Well, it's already got the TBDs, but I don't think it has everything else it
Everything
needs.
else, And the snippet that I sent is the process. There's the requirements, which is section 2 from memory.
Yeah.
So take care of that, and you might be able to do that from that just going forward the house. And as soon as that consensus is called on that, then submit my approve done.
Okay. Thank you.
Thanks, guys. I'm going to get it. Hopefully.
Take care.
Is he sick?
Yeah.
I need to see that. So for the API presentation, which is fairly late.
Yeah.
Yeah. If the time is short for that, I will probably do it not Bing because it's more, But if we have plenty of time, then
That's fine.
Bing can do it and I can assist. But we really would like to do it because I want to get the people in the working group, if anybody comes, thinking that the API is something they need to study because my opinion is if the API is broken, then the protocol is broken. So we need people to look at it.
Okay. To fill another page to discuss third stage, or we'll do that in minutes.
So first of all, we're missing a mute mic button, so that's kind of. It would be good if we had a mic between us.
Okay. Yeah. Okay. If you want to do our slides, you can do the slides after the board.
I don't have any. We don't have any slides. I think we can.
Do you want to make one? No.
No, I can just talk to it without it. So whenever you think is the right time in the agenda, you can just.
All right. After this. Okay, guys. We are running late. Sorry about it. This is the Anima session 2. On Monday we have session 1, and we give the priority for the working group work items. That's why we haven't finished our agenda on Monday, so we still have the autonomic control plan today. That will go first. Then we'll continue with the non-chartered work items. Information distribution over GRASP, which should be presented last meeting, but we only have 1 hour for our second session in Buenos Aires, so it didn't get presented. It go first, then that's autonomic function coordination by the example. Hopefully we could understand better how coordination may work, and the autonomic function life cycle and management. Follow-ups, that's our favorite Anima intent policy. We already discussed a lot on that, but still we haven't reached the kind of agreement in working groups yet. However, we don't have pressure to do so until our recharter. Then GRASP API, we really hope we have that time to make the presentation on API, because we do think that's something essential. If the API breaks, the GRASP breaks, then all the other components may break. Okay, that's the agenda for today. So, Michael? Let's see. Which one? Which one? Oops. Yeah. Go ahead.
Thank you.
Can I say anything?
Yeah.
Can I say this?
Yeah.
Yeah.
Thank you
Okay.
very much. So this is the autonomic control plane presentation. Next slide. In its third IETF revision, just as a quick reminder, the behavior of an autonomic node is such that if it detects nodes adjacent to it that belong to the same domain, it will create an autonomic control plane to that neighbor. And there are various other cases which don't belong here, but that's the case that we are focusing on right now. Next slide. Next slide is the big slide, and this is largely overtaken by events now, actually. So this is the old slide that I prepared before the meeting. What is the current consensus? Brian, do you want to summarize the consensus that we have right now? Because I'm not 100% sure I get it right. Tell us this. Good.
No, I was just trying to have the.
Okay.
We cannot say that.
So let me see whether I get this together right, and I'm sure you'll correct me if not. There is insecure and secure grasp. Insecure grasp will be used before the ACP is set up. And there may be also MDNS. So I think the current proposal is that a proxy node speaks both, or needs to understand both grasp and MDNS. Is that your understanding, Michael?
I was offering to summarize for you.
Excellent.
To get to the microphone faster. I was going to say that, pardon me? My name is Michael Richardson, and I'm at the microphone. That we will run a separate instance of GRASP in insecure mode on proxy nodes and nodes which are looking to track ACP connections, and that it will be primarily in a multicast announcement mechanism, and that there probably is nothing to write. There's nothing you almost never listen to the network except for other multicasts. And it doesn't share anything with the other instance except maybe code. That's, I think, the summary.
And what was our decision on MDNS so far?
And that proxies may or should also announce themselves in MDNS.
Okay, so
That's
Details to be still
right.
formalized.
May or should,
Right.
to be determined. That's it. And if you don't intend to run an ACP, then you probably don't have GRASP code. That's the summary.
Yeah, possible.
You have a really
It's
big
optional
room.
in that case, I think is strictly speaking correct.
Pardon me?
In the case that the node does not build an ACP, GRASP is optional. May.
To be determined, I think.
Okay. I think there's a lot of fine tuning to
Yeah.
be done, but by and large, that seems to be the consensus.
Okay, as working group process, I should first ask whether there's anybody against such summary. Apart, may or should. The next question I will ask is the may or should, decided by the working group. So do you have any?
I have a
issue?
comment directly to the point you're making.
Okay, go ahead.
As per the conversations here, I agree with everything that's been said as to a summary of the conversation that's been happening at this meeting here at ITF. The next step was to write down exactly what that would look like in normative language. And I believe that we have notes for that at an email thread and are planning on turning that into what it would look like as a normative addition to the GRASP document. I would like to hold off on the census of the room or a hum or a vote on that until we see what that normative text would look like.
Yeah, okay,
Yeah, we are not ready for that, I agree.
yeah. That is,
Tullis. So yeah, so I've been vocal on kind of my opinion as an individual contributor in one direction, but when it comes to rough consensus, I'm pretty happy with either way it goes, right? So no, that's strong opinions. I think the one thing that might be a good reason to figure out when we want to come to the final conclusion is that we have from the Bootstrap side the ongoing work to figure out how do we deal with the co-op option. And I think at this point in time, it looks a little bit like we're trying to move it all into the co-op draft and basically then figure out which working group that should go in. And I think as part of that process, we would also, I think, need to figure out how much of the co-op option for using of the ACP we want to have in the main ACP draft or in the same or an associated co-op specific draft, especially when we go with the co-op option to a different working group. Maybe also how do I adapt the ACP to work with co-op might also rather go into a separate draft and the main Anima draft just stays with TLS, right? So I think that's one of the decisions we still need to make. And in that context, I think the people who wanted to have MDNS were primarily interested, I think, in the combination of MDNS with co-op. So that's why I'm then raising the question of where would the MDNS option ultimately need to show up?
I think if I were to summarize that, I would say that there are a number of questions been raised around co-op and MDNS that are more applicable to IoT or more constrained devices. And part of the churn within the working group has been to say how much of that is in scope directly within our documents and how much should be pulled out into separate documents but within the same working group, and how much should be pulled out into separate documents to be addressed in a different working group. And that would be an interesting question for the room.
I'm not sure I'm entitled to ask such a question, because if that's out of scope, then that's out of scope.
Right. So, but let's say one possible outcome could be that both the ACP and the Bootstrap draft wouldn't mention co-op at all anymore. Maybe not even MDNS, but that would all go into a co-op draft. So that would be a possible outcome that simplifies the situation.
Okay. Yeah.
There's another question about the discovery has to be described in both the Bootstrap draft as well as in the ACP draft. That's also something we need to still figure out how to do that, right? So ideally we describe it in one document and in the other one we say see section X of the other side. And then here we are not talking about the bootstrapping, here we are not talking about nodes that need to be bootstrapped, but about nodes that we need to establish an ACP with.
For that question, what the procedure I would like to say is, for you others talk to each other first, come back with a solution. You can report that on the mailing list. Don't wait for the next meeting. Then, we can go from your solution, yeah, to say whether there are people against it or not. Yeah, if there's nobody against it, go for it. Yeah.
And I think the core really is how GRASP is being used in the ACP by registrar and bootstrap proxy. So I think primarily that's Brian and myself working on that, and then we'll expand to Max and the working group.
Yeah, sounds good.
Brian Carpenter, unofficial JavaScribe. Just to tell you, there's at least one person attending remotely, so please do give your name at the microphone and speak close to the microphone.
Could you do so?
Okay, next slide, please. The certificate requirements, yes. So that was a pretty long discussion going on. What needs to be from an Anima perspective in the LDEF ID of a new node. And the thinking here was the following. Number one, we want to not use the usual fields, organizational unit and so on, because that is likely to be used by an organization for their own purposes. Okay, so that is observation number two. The next thought was, well, if we shouldn't use any obvious ones, let's create our own ones and make sure we call them anima.something, whatever. And that turned out not to be a good idea either, because all the CA software, RA software that's out there, which we will have to interoperate with eventually, would likely have trouble with new certificate fields. So the conclusion is the most pragmatic approach is we use, and that's the suggestion right now, looking for your input, we use actually the subject alt name, which is a standard field, and in there the RFC 822 name, i.e. email, and we format it in a way such that we have all the information in there. So that is a little bit of a hack, but I think it's a pragmatic hack. You have all the information there, but you are not, well, you're unlikely to collide with something that a normal operator may want to do for those certificates. So at the very bottom, you see the example, and Turnus came up with that. So the proposal was we call it anima.acp, and then plus the ACP address of that node at, and then the domain. Right, so this is the domain in which the node is, ACP address, and anima.acp is sort of a brief.
And Brian Carpenter would say we need to use lower letters for the IPv6 address. So.
Well, this is Brian Carpenter. I was going to say that, but I think my actual question is this name case sensitive? Or is it like an email address which is not case sensitive? Someone is muttering in my ear that it would be case sensitive. So whether you follow the correct recommendation or not, you should certainly document that it's case sensitive.
Okay.
Michael Richardson, I'm pretty sure if you use RFC 822 name, if your reason for using RFC 822 name is to fit into existing CA software, tell me if that's the case, then I'm pretty sure that you're going to run into, canonicalization and case sensitive issues on this. But more importantly,
that's the thing we just have to get right? This is a question.
Yeah, I think you need to justify this hack as, you know, why is it you're not going to subject alt name with an other name with an OID that we register? Yeah. Okay. I've actually written that code in the last 6 weeks. It's not so terrible. It's a little bit, there's a little bit twisty mazes of stuff, of documentation, but it's not so terrible. But I think the more important point that I want to bring up is that I'm not sure that at the point of time of bootstrapping that we know the ULA address of the node.
We assigned it at that time. And so remember the address. I
Yeah,
have-
so we derived it from the hash of something else, is that what you're telling me, right?
Right.
And so the node can come to know what it's going to be.
Yes, so
And-
I have a slide on the address concept later if you want to push that
Okay,
out. But
all
bottom
right,
line-
so I think I just want to raise the point, which is that the new pledge that's joining the domain has to know all this information in order to ask for it in its certificate. So we can't put things in there that it couldn't possibly know yet, or which we wouldn't want to reveal to a random stranger, okay, who is not yet enrolled and may never be because they're not who they say they are. So we need to think carefully about the privacy versus utility. We also
Michael,
yeah.
just to quickly answer to that, that is why in the Bootstrap 03 there is the explicit mentioning of the request CSR attributes.
Right.
So-
Yes, I know that. Yes, I know that. But I realize this. But the point I'm trying to say is that someone knocks on your front door, and you say, "Oh yes, of course I have a GE washing machine," and they're like, "Oh, that's great. Now I know what to steal." Right? Okay. So that's the point, right? You sort of like you just hold somebody some information, right? And they were like, they didn't even ask you what kind of washing machine they're going to sell you.
No, wait. In the Bootstrap, the sequence is the pledge authenticates to the registrar. Then the pledge asks for what attributes should I put in my certificate. Then this certificate signing happens. Where do you see the hole in that
okay,
logic?
so I'm not sure that the pledge is completely authenticated at that point. But maybe you're right. Maybe it is. But I wanted to say that it might be that for some things that we want to put in there, that for some additional things that we might want to have in there, that the answer is that having joined the domain, that afterwards you say, I really should have asked for this other things. That's okay. I'll do a new rekey of my certificate, and that we may want to write that down as acceptable because we don't know all the things we want to put in at the initial point.
I think we do.
That's my point, is that maybe we don't have to think so hard. Maybe it's better to give ourselves an out rather than trying to figure it all up front. That's all I'm trying to say.
I'm not sure if we can, conclude this here, but maybe just, on the mailing list, come up with an example.
Slide. Let's go on the next slide.
Hang on, before you go, I had a question to your question. This last line, I was not quite sure whether you were suggesting that we need to document really well while we're doing that, or whether you say we shouldn't do that.
I'm saying that if we have whatever our motivation is for overloading RFC822 name, we better document, have a good reason for that.
Thank you.
Okay? And otherwise I think we'll get massive pushback and we'll be told there's other name for that and we should just go get a OID and be done with.
And that is a discussion we should have. So
Yeah.
if anybody has a view on that, this is a proposal at this point, right?
Okay.
And I think the first reason, just as an example, was we would probably need two OIDs. One to identify the domain name that we have, and the other one, the V6 address that we have. So also simplification. Okay.
So you don't like the hack bottom line? Okay. Okay.
I'm actually Xing, without my chair hat on. I'm going to ask and maybe argue with you, why use this kind of naming, because I'm pretty sure when the RFC 8/2020 appears, there's no IPv6 address. So whether it's suitable we put IP address there, it's another issue. And second, I don't think such name is anything helpful readable. The reason we have a name instead of an IP address is we want that name to be meaningful and to be readable for human being somehow. And by putting IPv6 there, I don't think so. I don't think we reach the readability.
Yeah.
Then we may lose the reason why we have a lab.
I'm sort of with you on that. At the same time, I think we want to make this more explicit, maybe, that those things that we do in the autonomic domain do not necessarily have to be human usable. They can be machine usable. They need to be unique. But at the same time, same comment as to Michael. This is a discussion we have to have, right? These are good points you're making. At some point, we just need to call a day and say, this is what we're going to do. There are millions of ways of doing it.
I mean, in that case, I'm fine, if you say, even if you say that's some kind of ID for certain objective, which means we don't want readability. By the name of name, you actually means it's for human.
Let me ask that way. If we assume this was in the last call of the working group and you would read this line, would you object? Right? Because nobody, I mean, this is a wacky concept, right? So everybody understands that.
I'm not really object for that, but I will argue, we could find a better solution, better alternative.
Yeah.
Yeah.
Okay. So this is a discussion right now. All doors are open. Michael, do you have an idea who we could ask? Who would be authoritative for that type of question without getting us in a rat hole?
Michael Richardson. Well, I would say somebody who is part of the PKIX working group in the days of yore. Point at Stephen Kent, Russ Housley, Tim Polk. There's 4 or 5 other people I can think of, one who was standing in the front of the room.
They will have a view on that anyway at some point, right? So we might as well ask at the beginning.
I think your point 3, but use a standard field, otherwise in practice, integration problems on CA side. I think that really needs to be, again, I think that really needs to be clearly articulated, because out of the box, OpenSSL doesn't have that problem.
I think we have a section in the document about that.
Okay. Please
provide your input on that. And the same goes for the working group. Anybody else in the working group who has a view on this address? Yeah, it's identifier. No? Okay, then let's move on. So here's the addressing bit, addressing part. So that used to be a separate document, is now part of ACP. This is the proposal how we do addressing inside the ACP. Note we had 2 proposals, we have cut it down to 1, simply to, if nothing else, get a reaction, right? So this is, again, not cast in stone, but it is the current working proposal. And the current working proposal is the second one of the ones we had originally with the VBIT. And so in a quick recap what it is, so it's a ULA address, it starts with FD. In the first 40 bits, we make a hash of the domain name. That renders those 40 bits, the first 48 bits, in fact, pseudo-random. That's corresponding to the ULA specifications. We then have a type field, simply so that we are not stuck with this one single addressing scheme, but if in 2 years we need another one, we can make type 2. Then we have the zone ID. The zone ID at the initial bootstrap is always 0, and that means it is essentially an identifier, not a locator. And actually, if you look precisely in the email address before, there was a 0 in there. Those are those bits here in the zone ID.
Michael, there's no need to go over that again. Just focus on the difference.
Focus on
differences.
So
yeah,
this is the second proposal from previously, with the only difference that we have now said the VBIT is 1 single bit. In other words, now we are able to say with the last bit set to 0, we are addressing the main node. With the last bit set to 1, we are addressing a virtual machine that runs on there. That allows us to nicely keep routing aggregated, so we can announce a /127 for the node plus any other system. There are many other ways of slicing that. It is a proposal, and we want to see how it sticks, right? If anybody has hard feelings about this or reasons why this is not a good idea, please speak up. We want to make progress on that, and we want to, at some point, make a last call on that, right? Okay, next slide. Yeah, this is just a visualization of the concept. So you have the AN forwarding element that has the last bit set to 0, the A controller element that sits on top of that, that gets a last bit set to 1. So basically, you have two entities, logically speaking. And on the wire, you announce /127. So routing stays nice and clean, yet you have two addresses. We could make this V bit bigger, so lots of options. That's the current proposal. Next slide. Yeah, there used to be an ACP without separation section. We had long time agreed to get rid of that. Now it has happened, so this is nothing new. And editorial changes, and that's it, I think. Okay. Any other comments, thoughts? Big request on everybody. There are things in there which we need to make a decision on. If you, especially, so have a look at those slides. If there's anything in there that you think we should not do, please shout now. This is the moment, right?
No, you cannot say so. Yeah, I mean, people, please read this draft. If you have any question or anything you want to bring out, you can do so on the mailing list even after this meeting. Yeah.
Yes. You say it much nicer than I did, but I meant to convey that.
Yeah. Okay. All right. Thank you, Michael.
Bing Liu, a very simple question to the VBit. Why is there only one VBit?
Because we picked it such.
But
sorry, I don't mean this to be flippant, right? We had in the previous version V equals pick a number, right? And at some point we need to pick a number, and we could have picked V equal 2 or 3. So the last 2 or 3 bits that would give us more virtualization possibilities. We can still do that. But this is exactly the discussion we need to have. So if you believe it should be more than 1 bit, please speak up and let's take that to the list.
As the picture it was meant to show, all the ASAs would run in a simple PC, which usually has one address, and then we have the router, which we call the forwarding element, which does all the ACP function, and that has its own address. So we try to get away with as few as possible, so that whenever we start having arguments, you need more addresses, somebody should explain why.
okay.
And
Thank you.
just a floppy remark, you will notice an empty space up there. That is because on the previous version of that slide, I had 2 on there. So it is a little bit random right now, right? So any argument is welcome.
Thanks. Thank you. So next. B.
Did we quickly want to put the...
Oh, yeah, in just a moment. There are something. Got it.
Yeah, so just a quick flow over from GRASP. So for GRASP, we need allocation of addresses from IANA, a UDP port, TCP port, and a linked local IPv6 multicast address. So we relearned from our AD, again, the official process, and that involves that we're kind of having working group review on that. So we'll go through the step. You saw the AD sending the process, and we're going to make a roll call then so that we can get these numbers allocated already before the draft is in RFC, which just, makes it not something when we're going through last call, then something which may tie us up unnecessarily, but that, even prototype code can already start using then.
So we'll just send out an email to mailing list.
Yeah.
To do the process. Yeah. Okay. Okay. Could you try to speed it up a little bit? Okay.
Good afternoon, everyone. This is Bing Liu, talking about the information distribution over GRASP. Next, please. It's a brief look back of the first version. we discussed the technical requirement, mainly two parts. First one is the node behavior. There are several basic behavior: the flooding, the selective flooding, and point-to-point. This is very natural and straightforward. For the flooding, we need a loop avoidance. We'll talk about later. And the second aspect is the protocol requirement. And we need to indicate the message that need to be distributed to make it aware by the ESA that it need to distribute this message. This is quite basic. And the second, for the selective flooding, we also need to indicate what's the what part of nodes should be distributed rather than all nodes. So that's the essential content of the 00 version, two aspects of requirement. Next, please. So this is a comparison of the latest version. We also followed the requirement analysis. For the loop avoidance, it was actually added into the graph protocol. Now, because graph introduced the flood message, so it needs to have a loop avoidance mechanism. So it is now integrated in the graph. And for the selective flooding, there are some mechanism introduced in this new version we'll talk about later. And for the indication of the distributed information, actually in GRASP version 2, the working group document version 2, we introduced a new flood synchronization message. It is just act as an indication of what kind of message and information should be distributed. And for the selective flooding indication, also in this version, we have a mechanism. So this is a comparison of the two versions. What's the difference and what is added in this new version and what is already integrated into the basic GRASP protocol. Next, please. So for selective flooding mechanism, we define a selective flooding criteria, which consists of the three elements. The first one, we called it matching condition, which means the criteria of selection. For example, for the devices that its role is, for example, the IP run RSG, it should be distributed with the information. So that's the matching condition. And then the matching objective. There's two situations. One situation is the condition is matching for the node itself. And the other one is the matching condition is for its neighbor. So the action is if the matching condition is true, then there's some behavior need to be done. So that's the selective flooding criteria defined in this 0.1 version. And for node behavior, the distribution initial node includes the selecting criteria in the distribution information. Here's the open question. We have two alternatives. One is we can include these criteria directly in the graph message, or we can also include it in the distribution content. So we need to have a choice. So this is still an open question. The second behavior, once every autonomic node receive the distribution content, it need to interpret the selective flooding criteria. So when the matching objective is neighbors, the node only distribute information to neighbors who match the condition. And if the objective is the node itself, the node will terminate the distribution. So that's the two actions. So here are a few open issues. The first one, do you think it's needed for the selective flooding? And here are some basic pro-cons analysis. For pros, we can avoid some unnecessary message amplification. Okay, Michael first.
Just a quick check. We did have some meetings where I'm not quite sure how official they were. So this may not be official, but my understanding was that we sort of had decided for now against selective flooding. And if so, if that is the working group consensus, which I'm not entirely sure, what should we then do in this document?
Actually, even we run this as a forum for potential work item for next charter. So for now, we are still not a working group working on this work item totally. So there's no working group consensus at all. I mean, that's not a working group draft yet, and we are not planning to adopt it under this charter at all.
So if we are not working on this now, why are we presenting it?
Because we always run the second session as a forum
I thought this is for deciding what we are going to do.
No. That's not a question to decide it now. No. Yeah, that's fine.
And I think what we discussed during the week was purely what type of flooding do we need for registrar detection by proxies. And there we do not need constrainment because every device should be a proxy, but that's the only state we made. We didn't make any statements about what other ASAs would need.
This is the information distribution draft. That's about intent distribution and other things. And my understanding from all the discussions we've had recently was we decided for now we will not do selective flooding. We keep the door open, right? We may need it at some point, but we're not, never mind.
Laurent Chavalia. I think that the change from intent distribution to information distribution need to reflect that we are looking for a greater scheme to how we can convey any type of information using Anima mechanism.
Exactly.
Intent is one of those mechanisms, and I agree with Michael that in the context of intent, so far, even if it's not a charter work item, we tend to avoid selective flooding. There is no decision on that. It's just that in the context of intent distribution, we have no case today to say we need to be more selective. In the context of information distribution, since it's a wider scope, how do we handle this sub-case? Just to clarify a bit.
Yes. For intent distribution, basically I think it's good that we don't have the sophisticated selective, but if we have a broader, wider scope of information distribution, personally, I believe it's a useful mechanism. Okay, some other open issues. So number 2 is lifetime management. For the short-term content, maybe it's good to include lifetime so that each node receive the distributed content, it can know when it will be expired. But for the long-lived content, for example, the intent, I know we haven't have a consensus of how long intent should be, but comparing to those very inferior content, the intent should be at least longer. So for this kind of information, maybe it's not necessary to have a lifetime in the content. The node just passively wait for the update from the initial, from the source of the distributed content. And number 3 is verification of distributed information. There's 2 aspects. The one is the integrity verification, which means the distributed content has not been modified by any middle boxes. So by default, because Grasp runs into ACP, but ACP can only provide confidentiality. So we might need a digital signature of the content. Probably according to the domain certificate, it should be sufficient. And the second aspect is the source authorization verification, which means the node, when it receives the distributed content, it needs to be sure the source has a privilege to distribute such content. Yes, Michael?
I think Brian just spoke to me quickly on that. I think the ACP is made with tunnel types that very likely also provide integrity verification, and anti-replay, it's IPsec tunnels, for example, right? So the dot here is factually not quite correct. However, I think you probably still want that. You want to validate who has actually ingested it. So you want to nail it down to a particular node type and sign it. That's what you mean, right? Okay.
Okay, thank you. Next, please. Oh, okay. The fourth one, the autonoid domain boundary. As in last ITF, or maybe the one before last ITF, Michael suggested that ACP has a boundary implication. So for the non-ACP mode, it should be out of the scope of this document. But may I ask Michael to comment a little bit on this? Thank you.
Michael Berenger, I'm not quite sure what that means, has the boundary implication. You mean that the ACP will naturally prevent it from flooding elsewhere?
Yeah, the boundary means the node need to know, okay, now I'm the termination of the message. Then I won't give the message to any other. So this means if I don't have any ACP tunnels, then I just don't care about. Is that what you argued?
That is what I've been arguing, yes.
Okay, okay.
So the boundary is implicit.
Okay.
Where there's no tunnel, there's a boundary.
Okay, thank you. And the fifth one is arbitrary injecting point. Ideally, the content could be distributed in any node, then to every other node. So should this be a requirement, or maybe it's too ideal? And the sixth one is a confliction handling. Because there might be different sources to distribute it, maybe the same content. So what if they conflict with each other? But maybe it's out of the distribution mechanism scope. Maybe it's something belong to, for example, the coordination function, I think. Okay, the last one is it's a replication of the previous one.
This is Max Pritikin. I was going to point out that there was a duplication, but I have a question about it. Max Pritikin. In order to do source authorization, we need some concept of who is authorized to do the distribution, which is, if you take a look at the draft for the selective flooding, it's the same, or it's a very similar side of the problem. In selective flooding, what the draft says is that it would look at the authorization who it sends the data to and decide whether or not it should send it to it. This is the other direction where you receive data and decide whether or not it was supposed to have come from there. I would put my vote in the ground that says we shouldn't do selective flooding. It's a bunch of complexity, but it might be interesting to discuss this question of source authorization verification, depending on the answer to number 5, I think on the next slide, which is to say, do we have arbitrary injection points? Because if we have arbitrary injection points, then any sort of verification becomes very difficult.
Okay. And if I can continue that, because I agree with Michael Berenger here. I also think we do not want intent injected everywhere. We probably want to control that by some policy. And if that is the case, one thing we have actually not done right now is we also need to set that in the certificate for that node, which node is authenticated to ingest intent or any other content, right? That's something that had come up before.
Max Pritikin, yes, very much. I meant to say that. Thank you.
Yes, thanks. Conflict handling, I think we should try to keep as simple as we possibly can right now. Something like keep latest.
Yes. So you're suggesting we integrate a minimal function to do this, not just simply make it out of scope?
Well, what I'm trying to say is you can have all sorts of ways of deciding which one you want to keep, which one you want to forward. This could become quite complicated. I suggest we define very well what is the identifier of an information bit. And then for that identifier, the policy is we always keep just the latest. And now, if we do this in a clever way that allows us to have as an identifier, for example, 2 different nodes, if we want, that both send intent. And depending how we select the identifier, if it's just intent, then we keep the latest, never mind where it comes from. If we say intent.node A, then we keep the latest from node A. If you see what I mean. So this is a relatively simple concept, and it allows us still to maneuver quite flexibly through what we need.
Yeah, but it depends on.
So we probably need a mechanism to tell which is the latest, and a trust, way for that kind of mechanism.
Yes.
Yes, but
I think this issue mostly depends on the definition of the intent format, intent content. If we can clearly distinguish the identifiers and the timestamp, the confliction handling should be very easy. Unless of that, it's very difficult for the distribution mechanism itself to handle this issue.
Okay, Laurent Chavalia, again, if it's the subcase of intent, we have some information on which to decide for this set of issues. In the more general context of information distribution, I think what we should have, and maybe for revision of the draft, is to consider what are the needs or the requirements in terms of information we need to exchange either between ASAs or between the elements of the ANI and the ASA, because this will give us a set of criteria on which to decide if we need flooding, selective flooding, level of authentication, injection points, and also concerning this aspect of, the caching of information, replication of information, way to optimize the storage and the distribution schema of the information. We need to have a set of, not talking about a requirement document, but that we try to identify maybe through some use cases, what are the general requirements we want to cover with this information distribution. Because also there are several existing techniques or architectures dedicated to information management in distributed systems. And we may compare to that and decide whether in Anima we need to fix our ideas towards grasp or combine with other mechanisms.
Okay, thank you.
Just a question, would you be interested to contribute to that, to have just scenarios?
It's also volunteering to contribute. I think there are some links with this draft with what we have published last time on the knowledge function block, because it's also how to organize knowledge information between autonomic functions. Yes. And I can also share some pointers in the literature about systems which manage information or knowledge among distributed systems.
Yes. By the way, did you have the draft of the knowledge exchange as you presented remotely last IETF?
I will not present it today, but the draft is on the IETF repository.
Okay.
So.
Okay.
But we may discuss offline, and maybe for this draft, as I mentioned, have some inputs on the requirements and existing systems just to kick off the discussion.
Okay. Thank you.
Yeah, at this moment, this draft is out of charter. But still, I still encourage you guys to work on this draft and make it as mature as is possible. Then, because this is something we already identified, we need it for the autonomic networking infrastructure. So it's highly possible we may take that in next charter. If so, then, if you guys working on that, we may be able to quickly adopt when we come to next charter period. Thanks for that. But for now, there's no consensus. That's still individual draft. You guys can do it whatever you would like to do, as long as you guys reach agreement along the clauses. Yeah.
Yeah, understand.
Okay. Go ahead.
Thank you.
Laura? Which one do you want to go first?
Coordination by example.
Okay. I suggest you speed it a little bit. Speed it a little bit.
I can shorten a bit the other.
No. Take your time. But try to
okay,
be fast.
So this topic has already been discussed in previous working group sessions, but it seems that we need to go a bit more into some details, explaining with an example and with some more concrete information on the format and functionality, sub-functionality of this autonomic function coordination. Next slide, please. So the main objective of this presentation is first to show the actual feasibility of coordination functions between autonomic service agents. And the secondary objective is to allow us to identify some required elements that will compose this function, and also to derive a set of requirements towards the ASA or towards the ANA functions in support for this function. So the base network we are using is a network composed of a set of edge routers and core routers. We have some clients attached to that, a set of traffic and LSPs to carry this traffic among the different routers. So this is a very simple toy example. Next slide, please. So now we, in this case, we deploy two different ASA on one of the router, and it's replicated on the different routers if you wish, but we will focus on the router A. So two different ASA, a load balancing ASA. The role is to steer the traffic on the different LSPs in order to balance the load on the network, and a risk-aware routing ASA installed on the same router, which the role of this ASA is to avoid a risky path for premium traffic, for instance. So now I'm looking only at the traffic engineering ASA. So by definition, this is deployable on edge routers. Once it is deployed, it will do two things. It will monitor the load of the interfaces. This is the blue thing. And the other thing it will do is it will modify the routes of LSPs in order to balance the load. Next slide, please. The risk-aware ASA is also deployable on the same type of devices. And once it is deployed, it also do two things, monitoring not the load, but the risk level of an interface, of an interface. And it will modify the routes of a set of LSP. Here, in this case, it's the premium LSPs in case of a failure that has been exposed. Next slide. So this is just to highlight, with respect to the reference model figure, the positioning of the ASA and grouping as autonomic functions, and also the use of the ANI and the graph signaling in order to communicate, and also important, the enforcement of the control loop towards the device. These are the two main channels that the ASA are using in order to perform their operation. Michael?
Michael Richardson, the mic. Just trying to understand the previous slide so I can explain it to my grandmother. What would, can you give me a concrete example of what a risk of failure that you can monitor?
Yes, for instance, there are different types of systems. For instance, you can monitor some health indicator on a router. For instance, if you have CPU, memory leakage, but this is more, IT oriented, or for instance, in optical systems, you can also monitor some characteristic of the fibers or the transponders and anticipate on
like how much optical loss there is in the fiber or something like that. Is that what you mean?
How much, sorry, what?
How much signal loss that you're still getting signal, but the noise is going up or something?
Signal loss is one element, but it's not really the one used in
I just wanted to make sure I understood the concrete content underneath it. Thank you.
Yeah, thank you. Next slide, please. So now, just to highlight also an important phase, you want to deploy this ASA on the infrastructure. So the deployment is when you actually install the software that the operator has purchased on the different elements, and you connect this ASA to the devices. So during the deployment, you establish session or connection or communication channels with the devices, and there are existing drafts in the working group to do that. And also you collect a number of device-specific information. Once you install, for instance, the load balancing ASA, you need to collect how many interfaces you have, the characteristic of these interfaces, which type of Ethernet interfaces it is, for instance, specific IDs that have been configured. So you collect a set of information that are really specific to the device you are controlling. Then the ASA will compile this information in what we call so far an instance manifest, which is a data structure, and it will put in this data structure the actual matrix. So in the case of the load balancing ASA, it is the load of the interfaces it monitors. So what actual metrics on which actual interfaces it will monitor, and the actual parameters it will modify. So the explicit root object of a specific LSP. So this is the information it will put in the instance manifest. And this instance manifest then is shared, is distributed towards the necessary component in the ANI, which remains to be defined, and this is a bit the purpose of this demonstration. Next slide, please. So now we go a bit more into the details. So coming back again to the load balancing ASA, so we still have the same information. It's deployed over router A, monitors the loads, and modify the routes of LSPs. What we have now more, once we have installed this load balancing, we have more information. So on the left side, you have this diagram with the load balancing ASA, which is the ASA doing its function. The purple or blue things on the left, which is what type of information it monitors, the metrics. So this is the load of the different interfaces. And the red dots are the different elements it can modify. So here it will modify the roots of the different LSP, the explicit root object of the LSPs. So this is a visual representation, and one example of an XML format of this same instance manifest is on the right side. So you have the different fields, which ASA it is, the identification of this ASA, and you can see the mapping of the same information. So in blue, the matrix you will monitor, so interface load, what type of information it is, and which interfaces you are monitoring. And in red, you have the actions you can do on the network, so modifying the LSP path through the explicit root object on which LSPs you will do that. Next slide, please. So the dotted lines here show that by doing a certain actions, so changing, for instance, the explicit root object on an LSP, you will modify the load on the interfaces. So by doing that, you will have kind of retroaction, which that's why we have control loop, that doing something on the parameters will also impact the value of the metrics you are monitoring. And then, next slide, or next animation, you do that for all the possible combination, and you have a set of interactions between your outputs and your inputs. Next slide, please. Now we have a similar things, just to give you the details about the risk-aware routing ASA. So very simple. So you monitor a slightly different type of information, which is a risk level and not a load level. You modify the same type of parameter. You will modify also LSP, but not the same LSPs. And so you have, again, the same XML format, which is the same templates, but with different information, not the same name of ASA, not the same ID, different type of inputs, but or maybe the same content type, and also actions. And here, in that case, you can see that this is the same type of actions, but we cannot guess that. Next slide, please. So now you have a network with two deployed ASA, but you want them to operate, and you wish that it operates as you wish, not that it creates some chaos. So we need to go a step further to make sure that once you turn on all this mechanism, it doesn't break your network. So what you need, next slide please, is the approach we propose for the coordination function is first to be able to identify if there are potential conflicts among the different ASA. And to do that, we want to have some automation, some mechanism to help to support the operator not to do it by hand or just by guessing. So what you need as an input in the proposed approach is to use the information you get in the instance manifest, so the metrics and the parameters, to make it simple, from all the ASA that are deployed and active in the autonomic network. And the output that will come from this conflict identification, I'm only at the stage of identifying the conflict. The proposed approach is that you will issue groups of ASA that have potential conflicts, list of conflicts. These conflict identification functions can be installed in different places. So it depends on our design choice on the ANI, or it can be a client of the ANI, and it can be more or less distributed or centralized. Next slide, please. So this is just to show that for this example, we have put it on one of the nodes. It's not an ASA because it's not an autonomic function, but it uses also services of the ANI or functionality of the ANI to communicate with the ASA and with other components. Next slide, please. So now, how do you do conflict identification? Again, this is just a proposal. It's one approach. It's just to show that it's feasible. It doesn't prescribe anything for the working group. So one approach is to use a bit of graph theory, very simple one. So you have the different diagrams that shows each ASA, inputs, outputs. It's very simple. And what you want to do is to combine the different graphs, the different individual graphs of the different ASA, put them together, and then you have a bit of a more complex graph. But on that graph, what you want to do is one approach. Again, there are other solutions possible, but it's to identify loops, but special types of loops. The loops you want to identify loops that consider multiple ASA, and also loops that share edges among these different ASA. I think you can try to go next step. There is, I think, an animation. So if you run loop identification mechanism on this graph, what you identify is that you can go from, for instance, the risk-aware routing, and you go to the red-pink which is the action, and you will loop towards different metrics, and then you identify that you can have in the same loop the risk-aware ASA, the load balancing ASA, and they will share an edge, which is changing the route of an LSP. This is one way you can identify that these two control loops, these two ASA, have a potential conflict. They will act on something common. You don't know yet if it's conflicting, if it will help the network or break your network, but you can at least identify that they share something and you need to take a deeper look. So what we propose is that the output of this is that you have again, a format, whatever format you want to choose, but a potential conflict, you give it an ID, you group the ASA together, the two ASA IDs, for instance, and you have this shared to the coordination function. Next slide, please.
Just help me to understand this a little bit. Without my chair head. I mean, is there those red dots on the left somehow standard, or how do you know the, you know?
Can you just speak a bit louder because I have a bit of background noise? Sorry.
Can you hear me now?
Yeah.
Okay. Are those red dots on the right hand somehow standard, or are you going to stand that? Otherwise, you know, if we don't have a, you know, a standard way to describe, you know, those graphs, those graphics or whatever the items are, there's no way we can, you know, find the conflict.
Yeah, okay. So two elements to my response. This is just one possible approach using graph theory.
Yeah.
So you may have other approach to formalize how you want to identify conflicts. And to answer on the aspect of standardizing or what's behind the red dot, if I understand correctly, I will just go back. Yes, can you go back again? Again, back. Yes, here. So in terms of how you will identify that the red dots are common between different loops, is that here you have the instance manifest, and you have, for instance, the red part, which is possible actions. So you will have to standardize the format first, the template of what an ASA needs to describe as potential possible actions, and then if you see at the name, content type, and context, if you want to be able to identify that two things are the same for different loops, you will need to have a way to identify that what is written as LSP path, content type ERO, and the context are concerning the same things.
You know, this really makes me worried because it looks like, you know, somehow we should have a full list of, you know, possible action or possible impact on parameters, whatever, and we need to get everything on the devices in order to find potential conflict. But I don't think so far we have that information or even a list of full information.
Yeah. So don't be afraid. Again, this is a proposal, so we don't say that it's a perfect solution, and we are here to investigate that.
Okay.
The thing is that at some point, if you want to be able to identify conflict in an explicit manner, you will need to have something that you can rely that is common, either because it's a common description or because you have registered it somewhere similarly in different places.
Todd is echo too lazy to run to the microphone. I don't see the manifest expressing that there is actually a loop, right? That you're implying that the outputs will change the inputs.
What do you mean the manifest is doing what?
The manifest to me doesn't seem to imply that the loop exists, which should
No, it's not the manifest. The manifest is just an ASA, write down in a file or whatever format,
yes,
the metrics and the parameters. And then it's another function. It's the conflict identification functions that gather the different manifests and will kind of parse them, all the parameters,
Yes.
all the inputs, and then say if it's the same type of parameter or the same type of inputs. And by this approach, trying to find loops with common edges and different ASA, it means that they have interactions. It just says that.
Not necessarily bad ones.
Sorry?
Not necessarily bad ones.
No,
There
no,
are
not necessarily.
interactions.
It's interactions between two loops.
But what I'm trying to say is that the loop exists in your pictures. It's the dotted line back, and of course it's a correct picture, right? You change the actors and that will have an impact on the load, what you measure. But that is not expressed in the manifest. So when you're starting to later analyze the behavior of the overall system purely from the manifests, I don't think that you would know whether to assume that
Okay,
there is a loop or
maybe
not.
there is a slight misunderstanding. The dotted lines that are represented here is just to show that the ASA is doing something on a parameter on the node or on the network, and it has an actions on something it will monitor. If you go to the conflict identification graph, the dotted lines doesn't have the same meaning. The dotted lines is just to show that you can, go through the graph and identify loops. It doesn't necessarily need to be the same loops. I mean, the conflict identification function will reconstruct the loops. I mean, we build the loops in order to identify where are the loops. It doesn't get it from the manifest. It's an additional process you run in the conflict identification phase.
So then maybe I misunderstand what loop means. I was implying that loop means that a change on these outputs, on the red ones, impacts what you measure on the input.
At the ASI level, you have a control loops.
Mhm.
And in the conflict identification, it's not a control loop. It's a cycle in the graph.
I'm not really worried about that. Although we have loops here, but there must be some kind of condition. If the condition reached, we can get out of the loop. So somehow the loop could be stopped somewhere. It's not infinite loop.
Michael Richardson here. My impression, I think that my question is similar. My impression is that the great value of this work is that you haven't just identified where the the information leaks between different control loops are, but you've actually named them such that we could later on say, oh, this is the problem, that's where the problem is happening. This one doesn't have a problem, but this one has a problem. And so that would identify something that's gone wrong there. I don't know what happens next, but at least we have a name for this interaction. Interaction 3, 5, 6, 7, 4, 5, 6 has a problem. That was the number up there. Maybe that's not the interface. That's not the right one. But anyway, that's what I understood. Am I getting that right?
You are totally right. And
Okay.
especially what you mentioned is that in this, because it was the purpose of this example to go into, more details of a potential implementation, I will say. And this is why we have, what we call, runtime or instantiated conflict identification. In the previous time where we presented this work, there is, you can have an initial phase only at the deployment. You don't actually run your network, but if you say that in the specification of your software, I will modify A and another autonomic function will also modify the A parameter, maybe not on the same router. You can already identify that statically they may compete for the same A parameter. But once they are deployed, if they are deployed on completely different networks, they will not compete. And this is a case where you have deployed and you see that they are competing on the same resources. This is an instantiated case. So, okay.
You want to continue?
Yeah, please. So the output is that you can get a potential conflict or interactions between control loops. And then the next stage, next slide, please. Next, please. You can have another subfunction, which is actually the coordination you want to apply on this potential conflict or interaction. So the input is you get the output of the previous function, which is a description of the conflict identification. And in that case, we can also augment the description with more detail to say maybe what type of parameters, so in order to guide a bit the selection of the algorithm. And the output will be that at the end, you want to be able to impact the behavior of the different ASA. And for that, you need to issue some commands. Next slide. Okay, next slide, because this is not very important. So this is just some steps you can take in order to address the coordination part, which is what is in gray is just some potential refinement, but it requires also to have a bit more of information that are exposed in the manifest. So the first step is that you receive the list of conflicts. In the second step, what you could do is try to already identify the set of potential applicable algorithms, because you may have different types of algorithms that are more or less suited to different types of conflicts. Or to do that, you will need to have a better description of what is the conflict type, and also on the control capabilities exposed by the autonomy functions. If the autonomy function is just on-off, you are quite limited in what you can do to control the conflict. If an autonomic function says to you that you can tune a set of parameters, or you can stop some of my actions, it's not binary, you can have maybe some finer grain algorithm you can apply. The third step is that based on the type of conflict and available algorithm, you will choose a suited algorithm to address the conflict. In the fourth step, which is again a refinement, you may set already some parameter setting for the algorithm in order to handle the conflict. This may come from the intent, because the intent may say to you that, for instance, you want to prioritize that type of ASA in case of conflict over other type of ASA, because you put priorities on load versus energy or whatever. And also, again, the features that are exposed by the ASA. The final step you will always want to run is that you want to run the algorithm process in order to address the conflict. And for that, you will usually issue some commands. The basic one is just to stop or start an ASA, but you can also have other systems like random token, time separation, and more fancy also different algorithms. The next slide is just to show you one method that is not just on-off, which is to separate the operation of the different ASA with a time separation. So in that case, the load balancing ASA, which runs on a more continuous basis, you will run it with a shorter time scale, and the risk-aware ASA, which is triggered anyway by events that are related to risk of failure, will run on a longer time scale, and then you will, in the different period of time, avoid the conflict, the explicit conflict between the two ASA. Next slide, I think it's the conclusion. So a series of conclusion. We try to show with this example. Maybe it's not, easy enough to grasp, and we may develop a bit, but we try to show that it's feasible to do identification of conflict and resolution of conflict with specific data structures and specification of information. We have shown that what type of information needs to be conveyed between the different elements, what ASA needs to expose, what the conflict coordination function needs to get in order to make its processing, different possible format, and also a basic method to address this.
Sure. Thanks, Laurent, for this example. You're already talking about the coordination several times, and those examples is really help us to understand why this is important. And I can now, agree the great value for the coordination, but I still not convinced this work is doable, because if you want to make it generalized to be able to working between various ASAs or even random ASAs, I don't know how.
I think it's we are not at the end of the story.
Yeah.
Just to give you some proof points.
Mm-hmm.
Most of this work is something we have done a few years ago in a research project, and we had some, really proof of concept that we show for something like 6 to 8 different type of ASA,
Mhm.
we can do coordination using this method, and it's work on a, again, it's only a simulation example. The other proof point is that if you go towards mobile networks, especially 3GPP networks, they have more specific, they have more specification on the zones functions, and there are similar proposal in the 3GPP standards for method, or not method, approaches to coordinate the behavior of this function. So
Yeah, I have no doubt, if, those very specific ASAs and where the potential conflict may be, there's no doubt you can do that. But whether it's possible to do some generalization even without knowing, where the potential ASA could be, or try to, get the potential to serve the future ASAs, I don't know.
okay.
It seems a big challenge.
We can discuss, and
Okay.
we'll be willing to discuss that, but I don't see a clear, a very hard
Okay.
problem in order to generalize, to be generic.
Actually, you know what I'm thinking? I think we may form a research group to do that.
I think I have just one last slide.
Yeah, maybe just one question. Do you think that the running multiple of these autonomic functions together could be automated insofar as that the manifest could describe what type of, output, function or so it does, so that when you said the, what was the thing here, the coordination, right? So basically you're saying there is going to be some additional function being put in that kind of coordinates the otherwise conflicting overlapping output, that could automatically be selected by describing in more detail in the manifest
You mean
what they do?
having the possibility to choose the right algorithm in an automated way?
Yeah.
We have some work on that. We have been working on that. There are some things, but it rapidly comes there a bit complex, a bit difficult. Because then you start to go towards a bit of artificial intelligence things, and maybe machine learning can help. But
Oh, I was just thinking about very simple
the
things
more you
like-
provide information, the best you will be able to have a selection of the algorithm. But then it's in the resolution algorithm, there is not only one truth. You can apply a genetic algorithm to solve any kind of problem, but for some problems they are not really performing with respect to a very simple time separation thing. So it's also the fact that you can solve many problems with many algorithms. The thing is to choose the right algorithm in the right case. And since the group of conflict may also evolve very dynamically, maybe you choose something at one point in time, and then 2 seconds later, it's a very different type of conflict. And so maybe you need to re-optimize your grouping of conflict to address it with a different type of algorithm. It's a bit of an open problem. It's, yes.
Okay, thanks.
So you have one more slide?
Yes, just a previous one, maybe, I don't know. Can you just go back one slide? Oh, okay, no. So next and next. I don't know. Oh, sorry. Yes.
Yeah, but you can finish first. Yeah.
Can you is there a next slide after that? I don't remember.
Yeah.
No, okay, so just the previous one, and I don't need to say this, it's okay.
Okay, Bing Liu. Two questions. The first is, I think you're providing a very good example of how to handle confliction. But regarding to coordination, are there any other functions other than confliction handling, or the coordination just means confliction handling?
Sorry, you mean inside the coordination, if there are other sub-functions? Or?
Yes, I mean, apart from confliction, this specific function, are there any other functions belonging to the coordination?
Yeah, okay. It really depends. It's very arbitrary because you can name it coordination. Some people will call it conflict identification, conflict resolution. Some people will call it orchestration. So it really depends what you want to do. That's why, reacting to Michael Richardson's comment, it's that you have interactions, which is a bit the more generic thing we can. You have interactions between things. After that, it can be, beneficial or non-beneficial. And then what you want to do, it can be to improve, to increase the utility or to avoid conflict, to avoid oscillation. So it's a matter of convention, what we want to call it. But you can imagine other things. Just an example is that, for instance, with the manifests, you can identify that one function can help the other by providing, for instance, a metric, a measurement, in order that another functions can improve its optimization. So it's not a conflict, it's more like you cooperate between functions. This is something you can do. You can call it coordination or put it in another block.
Okay. So in Anima, what's your plan of the coordination? You just focus on the confliction, or you might?
Yeah, I'm not an operator, but we have worked with operator on that, and it was driven by their work. The main thing they are concerned is that if they deploy things that turns autonomically, is that they don't want to break everything when it's turned on. So the first thing they want to prevent is really conflict or degradation, oscillation, things like this. So this is one priority for them. If you turn on everything, you have this control, and it behaves well. Okay, we are already good. Then to do something more, I think it's the second stage. So yes, maybe conflict is a priority number one.
Should we kind of call it?
The second question is the confliction handling mechanism implies there should be a central node to gather each node's manifest.
This is also a design issue. It's true that if you have a central view, it's easier to address all the conflict, but in our work, we try to also have some approach where you can have multiple coordination functions and have also how to distribute the coordination functions with respect to what type of conflict or the type of conflict you have identified. So it doesn't necessarily need to be one central coordination.
But how to decide which one calculate the confliction, which one collect or others manifest?
It depends. It can be at the deployment stage. The operator will decide how much or how he wants to handle coordination in his network. It can be us in Anima. We define certain categories of networks or interactions we want to be able. It depends also maybe on the capability of the mechanism we will develop. There may be some that doesn't support distribution, some other may support that. There are a number of criteria we need to consider to make the design of these approaches.
Okay, thank you.
You haven't talking about this page, but by reading it, I like this page much more than the others, because that's something may be durable. You should document this requirement.
That's the next presentation. That's why.
Okay.
Because just to conclude, so in order to achieve coordination, there are a set of requirements. So, but this is proposal towards the working group, and it's not a charter work item, but you will need to have ASA to comply to a defined process. This can be the subject of an ASA lifecycle. You need, through the instance manifest, you get the knowledge about what the ASA does to the network. So this is the instance manifest. And then you need also to have means how to a bit control the behavior of the ASA. You can be more or less explicit, but then you need to have at least start-stop.
Yeah, that's fine. By the way, at the very beginning of your presentation, you actually list, you would like to get the requirements for both ASA and autonomic infrastructure. So I haven't said that part. Is there any requirements for?
Yeah, I've not maybe put it explicitly on the slide, but the instance manifest is a formalism we need to we could adopt. So this is one of the requirements for ASA, that follow this format and that they fill in the field of the ESA manifest and that this manifest is distributed in the ANI. The life cycle is another requirement. And then there is also the issue of this coordination block. Where is it in the Anima stack? Is it part of the ANI? Is it a client of the ANI? Is it using GRASP? Is it another protocol? How it communicates with the ESA? So there are some such design issues that we need to consider.
So, do you want to next presentations?
So the next presentation is a follow-up of this one, just to try to get an angle more on the need of a life cycle and how to manage ESA from a ANI point of view, I would say, or an operator point of view. Yeah, I try to be quick as possible. So it's based on two drafts that you see here. So the motivation of this work is essentially to be able to converge on a set of common guidelines, how to deploy and operate ESA or autonomic functions. Why? Because essentially you will have very different types of autonomic functions. They can do very ABC functions that are nothing in common. They will come from different developers and vendors. So you will have to address different ways of seeing the world. And then there is the fact that these autonomic functions, by definition, we want them to interwork and also to interwork with the ANI. So you have two types of interactions you want to be able to guide. And then next slide. The benefit we expect of providing the lifecycle and mechanism is for the operator, that the operator will concentrate on actually how to exploit the functionality that is provided by the ESA and not to concentrate what new type of mechanism or process he needs to learn or to deploy the ESA coming from Cisco or the ESA coming from Nokia, etc. So really to concentrate on making use of the network. And for developers, it's really the developer, they concentrate on coding the core functionality of the ESA and not to be questioned about if I want to deploy my ESA over these things or if I am from this vendor, I need to comply to these interfaces, which is not standard, and then I need to consider all the interfaces or drivers I need to support. So if we have a common interface, a common life cycle, the developer doesn't need to fix about that, it just needs to implement it, or it needs to take the library or the code that is available, or the specification that is available. Next slide, please. So this is a very early proposal, but has been discussed with some people in the working group. Main elements is a life cycle. This can be discussed, and there is no single life cycle we want that can be the only one, but it's a proposal. It also gives the information, the types of information we need to convey, the flow of information between the different entities, and possible data structures. So the three main data structure is the ESA class manifest, the ESA instance mandate, and the ESA instance manifest. I will go over that quickly after that. Next slide. So this is just the overall life cycle. Essentially, I will comment on the main stage. So undeploy is the stage where you are when the operator purchases the software of an ESA. So he has a piece of code somewhere, but it doesn't do anything. It's just a piece of code. He has maybe a documentation with that. But already here you can have what we call the ESA class manifest, which is, it can be a piece of paper or it can be a Java documentation, whatever, but this manifest describes what the ESA does, on which OS it can be installed, which parameter it will modify, on which type of device it can control, and what it does, what the objectives it supports, etc. Then if you want to, the operator will install, it will deploy a set of ESA on its infrastructure, but so this is what you have in the install state. You will actually install the software on some hosts, but they are not running yet. If you want to instantiate, it means really to deploy multiple instances, multiple agents of the functions on different devices. You go to the instantiating phase, and for that, you will issue a mandate. This is, you will give to the ESA the list of resources it needs to control, the objectives, the actual configuration that you want this ESA to perform, or the intent. So then you are instantiated, and once you are instantiated, going back to the previous presentation, you are able to expose your manifest, because the ESA, they are working on a specific device, and then they can collect the information, put that in the manifest, and distribute the manifest to the other component of the ANI. And then you have the lower part of the life cycle, which is once you're instantiated, either by default or not, you may run or you may wait for a command to run. And then you have the reverse pass, which is how to stop an ASA and revoke the mandate so that it's not instantiated anymore. And then you may undeploy and decommission the ASA.
Michael, make it short.
Michael Berenger, very quickly. This is a piece of software. At the end of the day, it registers with a port number on a host. Where does the registration, where does it become reachable over the port number? Is that at the installed state, at the instantiated, or at the operational state?
You have two stages. In the install, it's already reachable in order to send it a mandate. But it's a kind of void instance. It's just a listening to a policy port or a configuration port, etc. But we need also maybe to see with respect to the ACP when it connects to that.
So for the next revision, let's start to discuss those details as well.
Yes, for sure. So this is just what I have explained, so we can skip this slide. Yeah, next one, please. Okay, so the class manifest, what I explained is initially you had just a piece of software, but then the class manifest is to explain to the operator what it does, what are the characteristics of the software. Next slide, please. This is just taken from the draft and from another document technical report that we have working on. So to give you that, in the draft, we have tried to put in a very simple data structure the different fields you may consider in the class manifest to say what's the ASA is doing and what information you will need. This is very generic information. It's not instantiated information. And a potential XML format. Again, this is just to give you an example that it's feasible, it's not something that is not practicable. Next slide, please. So the instance mandate is when the operator will actually issue mandate. Maybe it can be at some stage the intent or configuration you will send. This is just very open today. So that you will need to give to the ASA what it needs to do, on which device it needs to install, what are the parameters, what you expect the regime of this ASA to behave. Next slide. So this is on the life cycle when the ASA will receive the mandates. Next slide is the instance manifest. So this is the outcome of the instantiation process. When the ASA is installed, you know all the instantiated parameters. So this is where you can build the instance manifest and you can distribute that to the other ANA functions that should receive it. Next slide. So this is this stage in the life cycle. Next slide. So once you are in the instantiated phase, there are a number of things you can do. So you want to be able to control when the ASA is running. So it's really to be able at least to stop. So and you need to have a way to do that. Today there is no specification in Anima how to actually turn on or turn off an ASA. It's by default, by policy, maybe we will turn it on, but there is no additional control level. Next slide. You need also to know what the ASA is doing, and if you think about the previous presentation, you can use that for coordination. If you have no way of, if the ASA is not exposing the different parameters and metric it's using, and then you have no way of assessing where it impacts. So this is the instance manifest we are proposing. Next slide. And also, but this is more about the deployment. You need to have also a way for the operator to express on which resources you want the ASA to be deployed. Otherwise, you need to deploy manually on each of the devices, which is, I don't think, something we want in Anima. Next slide.
One comment. I do think, the way how to decide would also be challenged. You probably need some mechanism or some policy, to make the decision on what? Decision on which ASA controls which equipment.
This is, I mean, the sentence, decide which ASA control which equipment, is the intention of the operator. The coverage, the planning he is doing. I mean, for instance, he wants to have a load balancing function to control its metropolitan segment. This is what is meant by that. You need to be able to list the resources, the devices on which you want to actually install and control with these specific functions. It's not always for all the equipment. You can have subsets.
Yeah, Thomas. So yeah, I think the part what isn't quite clear to me is you always say ASA, but I mean, if I have to deal with all the individual ASAs, that's so much work, right? So I think, wouldn't I, as an operator, like to have a view, you know, starting with the autonomic service function, lifecycle management, right? I want to basically now deploy and run a particular autonomic service function, which is something that expands across, you know, a whole set of devices, and of course it consists of a bunch of ASAs, but the fact that it consists of a bunch of ASAs as much as possible, I as an operator would love to ignore, except with, you know, very simple policies like I want this in my core, in my edge or something, and then this hopefully is just the underlay that...
I fully share your comment. I mean, what we have, I mean, in this presentation, we have tried to consider the existing or the existing defined elements in Anima. In Anima, we have the concept of AF, autonomic functions, but it's not specified. So I agree that we may need an intermediate level that is grouping ASA together and that is addressable maybe for the deployment or for reporting or for whatever use we want. But today it's not defined. So that's why here I was concentrating on to be very connected to the existing Anima specification. Next slide, please. So additional user in the sense of what are the functions that may use the life cycle and the existing information that are exchanged, the coordination function. But also we may think about if there are some functions used, meant to manage the exchange of information on the management of knowledge among the different functions. This can also subscribe to this manifest to collect the different metrics and parameters. So summary, again, the motivation is to converge towards common guidelines or to deploy and operate functions. And for that, we want to propose to define that we need to follow a common life cycle and a set of information flow and data structure that needs to be defined. It will help the operator and the developers in this stage. And the main thing is that we require, again, it's up to discussion for the working group, that we really need to have go a stage further in the definition or modeling of AF and ASA and the interactions with the ANA functions in order to define in the right way this life cycle and the manifest, etc. Yeah. And I think that's all.
Thanks, Laura. Let's move to next. Yes, you again. Another 8 minutes. Our favorite intent.
Yeah, and so this is very different topic, and really here, if we can have also a discussion with the room on the open issue, this is really the purpose of this presentation. So again, this has been presented in the past. It's the autonomic intent definition and format. We have a new co-author, which is Michael Beringer, for his contribution. So the main changes in the last version, version 4, is the introduction of a new section on intent lifecycle. We had quite a long discussion on the mailing list after Buenos Aires on this life cycle and elements of intent. We try to reflect on the life cycle part in this draft. There are still a lot of open discussion and open points to converge towards how the intent is distributed, what's the format, what are the intermediate steps to process the intent. Next slide, please. So I will try to go very quickly on that. It's the set of steps for the life cycle that is currently proposed. So there are steps to transform the business goal expressed by the operator into a machine-readable format of intents that is encoded as one or multiple files, and that will be given to the network. This reflects to the injection point of discussion that has been discussed previously. Step 3, once you have this intent file, it needs to be ingested some nodes, one or multiple nodes, and then to be distributed in some way. Step 4 is that the proposal today is to flood this intent to all nodes in the network without modification and without interpretation by the individual nodes. It's not that, at that stage that we want to process the intent, so that every node in the network, in the autonomic networking domain, will have the same copy of the intent file. Step 5 is where you start to go into the detail of the intent, and we propose to have sections that pertain either to specific function of the ANI and other sections that pertains to the different function or different ASA that are concerned. The ASA will be notified that there is some parts of the intent that are for them, and then they will need to process that. Step 6. So now you have all the ASA and all the nodes. The ANA as the ASA in every node needs to interpret their respective part of the intent, and it can be translated into a target configuration. So there is also here some local context that needs to be taken into account. And so for this translation to be complete, they may need to have exchanges between ASA in order to converge on some common parameters. This you can involve grasp mechanism. So just go back 1 second. That the communication between the ASA that results from that may be triggered by the intent, but we try to be careful not to call it intent. Next slide, please. So now that you have this target configuration, it's not really a step, but it's the fact that if you have other configuration method available on the node, they may supersede the intent. This is the definition we have so far in autonomic networking in Anima. Step 8 is that, again, this previous presentation on coordination, this is a stage where once you have defined the target configuration at each ASA level, it may impact the conflict identification and conflict resolution. So you may have to pass information to the coordination function in order to get the conflict resolution and then possibly modify or update the target configuration for each of the ASA. Once you have reached this step, you are able to apply the actual target configuration on every ASA and devices. The step 10 is more the feedback loop that there may be some condition or different type of aspect that you may want to be able to feedback towards the operator or towards the management system, depending on some consideration, deviation from standard behaviors or indesirable states. And just to mention that you can also have additional feedback that can occur earlier in the steps, like for instance, step 8.
I'm not convinced with step 8. I mean, the confliction of, I'm not sure that that's really relevant to the intent or not. In any case, I think we haven't really get convergence on the definition of intent yet. So we don't really have the consensus on what information should get into the intent. So I guess we should continue to discuss that first. What's the definition of intent and what information should be there?
We are touching that in some of the slides. Here, really, it's to highlight a bit the flow of the intent from the stage where it is defined, and we don't know what actually will be written, and how we may distribute and get every ASA gets the intent and may be able to process it. I agree with you that the actual format and content of the intent is not defined yet, but maybe next slide. So current definitions we have in the draft, so taken from the reference model and the RFC 7575, is that Anima intent is an abstract, high-level, declarative policy used to operate in an autonomic domain. One autonomic network can convey multiple intents. I'm not talking the intent file, but you can have multiple intent expressed by the operator for a single domain. One intent can create multiple output that the processing of the intent will generate different configuration for different ASA or for the ANA functions. Current discussion we had with the co-author is that the people that will write the intents are at the level of network operator administrator. It's not the end user or a customer. The autonomic functions will define what type of intent, or the intents they understand or what they expect. I mean, they need to express what type of format, what type of instruction they support. Next slide, please. So here it's not a complete list of open issues. It's just some of them and to trigger some discussion with the working group. So as there may be multiple intents and multiple outputs of intents, this may overlap or this may create conflict. We have seen in the life cycle that there may be a stage where we need to resolve that. So you need to have a step or a mechanism to be able to handle or to arbitrate between such conflicts. So this is an open point, and we need to discuss how to address that. For the aspect of the ASA expressing the intent they support, there is the question of creating an heterogeneity in format and semantics. So we will need potentially translation mechanism or standardization, registration of the different format and semantics. So this is again an open point, and we need to progress on that in order to go towards a workable solution. The definition of intent for the ANI functions, I don't think we have gone very deep into example for that. Modes of distribution of intent, so we have discussed a bit that before, but currently it's the default mode is to flood, but the question mark is still open for other approaches. So far we don't have very other counterexample why flooding is not sufficient or efficient enough. Next slide. Okay, so we can go back maybe to the issue after that, but this was just to, we have been working on this document for several meetings or several times. In the reference model for the, if I'm not really let the chair react, but the agreement is that there will be a description in the reference model about a high-level description, non-prescriptive description of what the intent is in Anima, and it will stop there. The intent specification is not a currently chartered work item, but at least personally, I don't know how you can operate an atomic network without any guidance from the operator. Otherwise, you configure manually and you deploy manually, etc. So just raising the question, any suggestion on the way forward for this work and how to bridge between what will be the specification of the chartered item and what will be the liaison with the new work. So the open issues and the future of this work is, I mean, for me, open for discussion.
Do you want to say something?
Do we want to directly move on to?
Yeah. Okay. Just one sentence. I encourage you guys to keep working on that. We already have a lot of discussion regarding to intent. One thing I would like you to do is just limit the scope to be, not generically intent, but the intent for, Anima networks. So personally, I believe that's a important work. We should, do that work after the charter. So keep doing, and hopefully we would have next meeting have much more time to discuss those. By that time, we probably already sent some chartered work item to ISG. So then hopefully we could have more time next meeting. Yeah, thanks.
Okay.
We still have one more topic to go, which is Brian. We start 3 minutes later, so we could end up 3 minutes later. So Brian, you have 6
Yeah.
minutes.
Okay, go to slide 3.
3?
So that's just a reminder of the implementation model for GRASP, but it's a little bit expanded because this also points out that you might have an extended function library when we extend the protocol in the way that Bing was mentioning earlier, for example, for distribution. But the API, which is going to be used by the ASAs, is highlighted there because that's the aspect of GRASP that the API writer will see. You will not see any of the internals, obviously, just see the API. So next slide. There's a couple of important data structures that we have put into the draft API. One is a data structure representing an objective, and I've shown this in a sort of Pythonish notation, but it's not definitive, of course. An objective has a name. It has a property of being synchronizable or negotiable. It's currently set up as 2 different Boolean properties. It has a loop count, which is a very fundamental thing in GRASP because you must control the loop count when you start an operation in order to make sure the operation ends within the number of steps or the diameter of network that you want it to end. And the value, which according to the GRASP spec is anything you want, and therefore according to the API, it's any data structure you want. Obviously, the interpretation of that is a little bit language dependent. Second very important data structure is an ASA locator, which is what you get back from a discovery message, which basically consists of a locator, a protocol, a port, and a few other less interesting things. Very quick question, Turles.
Yeah, so I think, is it true then that the ASA locator is the locator for the GRASP socket of the ASA?
Yeah, the socket, the protocol and port are for the socket that you're going to be using to talk to it. That's correct.
With GRASP. So
Yeah, with GRASP to GRASP communications. If you have other needs of communication to that particular ASA using some other protocol of your own invention, you know, well, we'll figure it out case by case, I think.
And I would usually be able to just share the IPv6 address for any other ports that I have in the value.
Yeah, exactly. Yeah. Okay. So a simplified summary of the calls that we have in the API. You need to read the draft to get the details. Register an ASA. And it's at that point that, in my mind, the ASA will get its instance ID, because actually what it gets back from that call is a nonce, which could be used as the instance ID. Register an objective. That's an ASA saying, I am going to synchronize or negotiate this objective. So the reason for registering the two things is so you can only have one pretender to be a certain ASA and a certain instance of GRASP, and one pretender to be the manager of a given objective in that instance of GRASP. That's an assumption we've made, which we could discuss, of course. And the other very basic call is discover, where you simply say discover objective, and you get back a set of ASA locators as a result of the discovery. So that's where those two fundamental data structures come in right away. When you do a discover, you use an objective to ask for a particular thing, and you get back ASA locators, which are the answers to the discovery. Next. These are the negotiate calls in the API. If you are initiating a negotiation, you use request negotiate. If you're going to be the responder to a negotiation, you use listen negotiate. If you're doing both in the same ASA, you will use both of those calls in separate threads, because obviously the listen is an asynchronous listen. Negotiate step, once you've established communication, either with a request or a listen, you can then, if the first proposal from the other side doesn't meet your satisfaction, you send back a negotiate step response, which maps into a negotiate message in GRASP. If you want to make the other end wait for a while, you send them a negotiate wait, which is another explicit GRASP message for basically pausing the negotiation while you perhaps negotiate with a third party. And when you've satisfied or dissatisfied with the negotiation, you can send end negotiate. If you're dissatisfied, you send a result which is false, and an error message if you wish in the reason parameter. If you're satisfied with the negotiation, you send a result which is true, which means you've accepted the previous negotiate step proposal. That's as simple as that. Next slide. Synchronize is even simpler. If you are the provider of a synchronization objective, you do listen synchronize. If you're the person who wants to receive the synchronized value, you use the synchronize call. They meet in the middle, and you get back the answer. And if you are a provider of flooded data, you just say flood. And that's it. Of course, I've missed out a lot of syntactic sugar in the calls. And by the way, that is the end of the talk. So, Michael.
No question for this time. We're already running out of time. So thank you all for your time. And I encourage you guys to review the working group documents. There are at least 2 or 3 we would like to send for IRSG before next meeting. we do need very good review coming to move them forward. Otherwise, some of them may run into trouble. So thank you all. Hopefully see you all in Solo. Thank you. Blue sheet. Just make sure you sign the blue sheets before you leave.